Okay, Bismillahirrahmanirrahim. Okay, guys, we are going to move forward into this topic of trigonometry. Hello. Okay. Okay, now, so we are on to this trigonometric equations. Okay. You must see that before this, we have covered this segment of the trigonometric equations. Like, if you look at these first two questions, we started with the simplest form of these trigonometric equations where you had tan x, sine x, and cos x equal to something. Okay. And then if you look at the question number 3 and 4, there we have seen that how to deal with the composite angles or the compound angles. Okay. Now, if we look at the questions after these two types of questions, now look at this question number 5, 6, 7, and onwards. Now you have more complex kind of equations over here. If you look at this question number 5, your equation is 2 sine x equal to cos x. Okay. Then you look at your question number 6. The equation has the sine and the cos, and there is a compound angle in it. Okay. Now, you have to be looking for two things in your trigonometric equations, or you should be trying to bring those two things into your trigonometric equations. One is, like, whatever kind of equation you have, you should end up with an equation like you have the equations in question number 1 and 2. Okay. Ultimately, your equation should simplify to the form that you have here in question number 1 and 2. Okay. You will have to apply those trigonometric identities, and then you might have to change the angle as well. Okay. Let's start with the question number 5. Now, question number 5 is a typical question where you have two terms, one in sine, the other is cos. Okay. In such equations, you will have to divide both the sides by cos x. Okay. In all these four questions, like for example, if you look at this 5a, now this equation is this is going to be 2 sine x that is equal to cos x. Okay. Now, what is the problem with this equation? We have both the sine and the cos in this one single equation. So we can either have the sine or cos or tan in our equation. Okay. So that we can determine the quadrants and then we can find that angle. Okay. So in such case, or in such cases, you divide both the sides by cos x. Okay, this is cos x, this is cos x, and that is going to be 2 tan x that is equal to 1. Now this has become an equation like you have seen in your first two questions. So you can simply say, okay, my tan x is going to be equal to half. Okay, and then you must know that at this level you have to mark the quadrants from, like, we have this 0 to 360. That is the domain in which we have to solve this equation. So please tell me quickly, what is this tan x? I mean, half, tan inverse of half. So, huh? 46.36. Okay. Oh, thank you, beta. 26.6. So the values of this angle x, these are, first you have this 26.6, and the second one is all of this angle, that is 116.6. Huh? No. Oh, I'm adding 190. Thank you, beta. I had 90 in my mind and 180, so I mixed them up. Okay. This is 106.6 degrees. Okay. Look at this D part. In this D part, you will have to do both the things. Now, this is going to be 3 cos 2x minus 4. Yes, but any question? Yes? Oh, what is happening here? Thank you, beta. These are such silly mistakes. Okay. 180 plus. Yeah, 180 plus. Yeah. Okay, thank you, beta. Please keep checking the answers, by the way. Okay, you must be checking your answers when we finish this. Okay, so these are just silly mistakes here. Now, you just see that what is new in this, that you have to divide your equation by cos x. So you can have one thing in your equation that is tan in this case. Okay, now this is 3 cos 2x minus 4 sine 2x equal to 0. This equation has got two problems in it. One, that we don't have a single trigonometric ratio in it. And second, we don't have a simple angle over here. Okay. So it is up to you that which one would you like to deal first. Okay. So you either divide both the sides by cos first, or you make your angle simple first. Okay. So let's divide both the sides by cos 2x. So by dividing both the sides by cos 2x, I have 3 minus 4 tan 2x, that is equal to 0. So my tan 2x is equal to 3 over 4. At this level, I would like to change this angle now into a simple angle, okay? So I would say let this 2x is equal to alpha here, okay? So my equation becomes tan alpha equal to 3 over 4. Now, when you have this alpha in your life, you must know its limits, okay? So when it was x was between 0 and 360. So this alpha is going to be between, what are the limits of this alpha now? 0 to 720, because when you put the lower limit into this relation here, you put x as 0, you get alpha as 0, okay? And when you put the upper limit of x, you get here 720 degrees. So that means now you will have to look for this angle up to 2 revolutions from 0 to 720 degrees, okay? बच्चों ध्यान करना है जरा आप मैं थोड़ा सा फास्ट हूं because I have to cover a lot of the part, but that doesn't mean that you cannot ask me अगर आपको कोई मसला है तो. So you have to be alert. You have to see that if there is anything that you people are not getting. Okay. So at this level, we have the equation in the simplest form, tan alpha equal to something. So here you have to determine the quadrants. Okay. So we are going to have this alpha into again the first and the fourth quadrant. Okay. So please tell me what is tan inverse of 3 over 4. Okay, 36.9, 36.9. So we always find the values within one revolution. So this is 36.9 and 216.9. And then you just add 360 into these two values. Okay? That is for from 360 to 720. Yes? So this one is going to be 396.9. The next one is going to be 576.9. So these are the values of alpha. So what would be the values of x? You will have to halve all these values, okay? So when you halve them, so you will have this x has to be half of alpha, okay? So you half all of them. Please tell me what do we get? This is 18.5. 18.45 means 18.5. 108.5 है ना? And 198.5 है ना? 198.2 198.5 and then 288.5. So these are the four values of your x. Okay. Sometimes it's really handy thing to just check your answer. Okay. So you have the calculators, you can quickly put any one of these values into your equation just to confirm that if your answer is approximately right, because we are rounding off these values. Okay. Acha bacho. Now, so these are the cases. Please remember, if your equation has only the sine and cos, you have to divide the whole equation by cos so that you're left with tan x in your life. Okay. Now look at, I should have a case very similar to it next to it. Yeah, look at this question number 7D. 7D, or Yeah, that is more important. Question number seven, 7 part E. Look at this 7 part E, bacho. Now, this is something very confusing because when the teacher says that, okay, if you have sine and cos in your equation, just divide the whole equation by cos. Look at this 7e. This equation also has the sine and the cos in it. Yes, we do have the sine and cos in it. But how to deal with this? Now, this is going to be 7e here. This is 2 sine x cos x, that is equal to sine x. Okay, I'm more interested in a question like this, which is going to be 2 sine x cos x, that is equal to cos x. I was telling you one thing in yesterday's test, that suppose you have x square equal to 2x. And now I was giving you this example that please never ever cancel your variable. What happens? You lose one of the values of x by doing this. Okay. So similarly, if you divide both the sides by cos x over here, so you see that you're going to lose one whole segment of this equation, because you see that you could have taken cos x as common as well. And you can take cos x as common, because when there are just two terms, like there is sine x plus cos x, that is equal to 0. So there is no factorization that can take place over here. There is no other option. We just divide both the sides by cos x. But you have to see that if you can factorize, if you can take common, please do that. Never ever waste a part of your equation. And obviously, when you're going to waste a part of your equation, you're going to lose some of the solutions of that equation. Okay, so now look at this, how to deal with this equation here. Now you will have to move this sine x to the left hand side. Okay, I was teaching to the O-level students yesterday, and I was telling them that if you want to avoid making a silly mistake in solving any kind of equation, just bring all the terms to one side and you make all your equation equal to 0. You will save yourself from making a silly mistake. Okay, so in this case, we'll be moving all the terms to the left hand side, and then you will see that yes, sine x will be common here. Okay, so this is going to be 2 sine x cos x minus sine x, that is equal to 0. So please take sine x common here. So sine x is going to be common. So we have sine x into 2 cos x minus 1 equal to 0. So we have either sine x equal to 0, or we have 2 cos x minus 1 equal to 0. Good students should always know the values on the coordinate axis. When do you have your sine 0? 0, 180, 360, and all the values which are like, coming onto this horizontal axis. So here you have x equal to, without using, because if you use your calculator will only give you the value 0. Okay, calculator will never give you the other values. So for that purpose, you will have to remember this is going to be 0, 180, and 360 degrees. Because if you look at this, this 0 and 360, they are both inclusive. Sometimes, bacho, you have it like this. You have x is going to be 0 between, this x is between 0 and 360, and you don't see the equal marks. And if you still include 0 and 360, examiner can deduct 1 mark for giving extra values. Okay? So you must know that, hello beta, you must know that if 0 and 360, they are inclusive or not. Okay? So in this case, they are. So we have to keep the 0 and 180, 0, 180, and 360 degrees here. Now this is going to be 2 cos x minus 1 equal to 0. Cos x equal to half. Okay, how many of you remember when is your cos half? 60 degrees. If you remember that, then you can also recall that sine 30 is half. Okay, so please remember these values by heart, bacho. Cos 60 is half. Okay, So you see, if you know this by heart, you can save your time that you will be losing on using that calculator thing. Okay. So cos is positive into these two quadrants here. Okay. This is 60. This is 60. So your x is going to be 60 degrees and 300 degrees. And at the end, you must write all these on answers in an order. This is 0 degrees, then you have 60 degrees, then you have 180 degrees, then you have 300 degrees, then you have 300. And you see, these are all the solutions of this one single equation. And if you had canceled this sine x with the sine x, you could have never got these three values over here. Okay, so you cannot cancel if you can take common. Okay, I hope you will remember this. So I think I have spoken a lot in this first segment of our lesson. You people can try question number 5, 6, and 7. Okay, I'll be telling you about the question number 8 onwards in the second part. Okay, so you please, this is your time to practice this.